This video provides an introduction to matrices. Now, matrices can be used to represent and process tables and numerical data. They can also be used to solve equations, determine solutions to problems in social and road networks, and encode and decode information. Matrix is a rectangular array of numbers arranged in rows and columns, and the plural is matrices. So you can see some matrices at the bottom of this slide. The numbers in the matrix are called the elements of the matrix. Each row or column of a matrix is a vector representing similar data. A matrix with m rows and n columns is called an m by n matrix. So you need to remember it's rows times columns. Now, the order or dimensions of a matrix is a number of rows by the number of columns. So a square matrix has dimensions m times n, so it means that m equals n. So some examples are at the bottom here. We have the first one is a 3 by 3 matrix, 3 rows, 3 columns. So that's its order. Matrix B is a 4 by 2, 4 rows, 2 columns. Matrix C is a 2 by 3, 2 rows, 3 columns, and you'll notice that the matrix itself, that capital is in bold. Now you don't have to worry too much about that. It's a bit hard for you to write in bold, but just so you take note of that. If a matrix has only one column, it's called a column matrix. And believe it or not, if it has only one row, it's called a row matrix. Now, the elements of a matrix are referred to by the row and then by the column. Again, row then column. So A13 refers to row 1, column 3. So you can see that A13 there. In general, Aij refers to the element in the ith row and the jth column of matrix A. A zero matrix is a matrix where every element is 0. And an identity matrix is a square matrix made up of zeros and ones, and the ones are on the diagonal, running from top left to bottom right, while all the remaining elements are zeros. Now, only square matrices have an identity, and we'll look at identity matrices later. Let's do some examples. For each of the following, give A, the order of the matrix, and where possible, write down the elements in B, row 2, column 1, and C, A22. Okay, so for the first one, our order is our rows by our columns, so 3 by 2. So for B, we're after row 2, column 1. So that would be row 2, column 1, which is second row, column 1, 3. C, A22 would be row 2, column 2, so that's the 6. Move across our order, 2 rows, 3 columns. B, A21, row 2, column 1, so that's -1. C, A22, row 2, column 2, so that's -2. Part 3, or question 3, the order, we have 3 rows, 1 column. B, A21, row 2, column 1, so -2. C, A22, we don't have 2 columns, so doesn't exist. Representing data in matrix form. So our minibus has 4 rows of seats with 3 seats in each row. So what I'm thinking about here, just to get an idea, is we have 4 rows of seats and there are 3 seats in each row. So we're looking at our 4 by 3 matrix, just in our head to get what's going on. Okay, so that's 4 rows of seats, 3 seats in each row. If 0 indicates that a seat is vacant and 1 indicates that a seat is occupied, write down a matrix to represent. So we have the first and third rows occupied. So we're going to have 1s in our first row, 0s in our second row, 1s in our third, and then 0s for vacant. The square brackets around the matrix. Next, only the seat at the front left corner of the minibus is occupied. So 1 in the first one, then everything else is going to be 0s. And we're done. Now creating an adjacency matrix from a diagram. 4 towns are connected by roads as shown in the figure below. Construct a matrix R that shows the number of direct roads connecting each town. So first, we're going to have 0s for A to A, B to B, C to C, and D to D. So that's a good one to start with. Then we go, if we look from A to B, we only have this one road here. So from A to B, we have one road, which means from B to A, we have one road. There are no arrows saying that these roads are one way. From A to C, we have 2, 1, and this wiggly road, 2. So that means from C to A, from A to C, we also have 2. A to D, we can't do A to D, so that's 0. So filling in both of those. B to C, we can't do. So filling in those 2. D to B, we have one row. And I should highlight it, which is that one there. And then the last one is C to D, and we have 3. 1, 2, 3. So that's 3 in there. So then we just write the matrix, and it's matrix R. So 0, 1, 2, 0, 1, 0, 0, 1, 2, 0, 0, 3, 0, 1, 3, 0. Now, entries and equality. 2 matrices are equal if and only if they have the same order and their corresponding elements are equal. So matrix A equals matrix B if and only if Aij equals Bij for all of I and for all of J, remembering that upside down A means for all. So let's look at an example. If A is 2, -4, 5, -3 is equal to B, x plus 2, y minus 5, w, 3z, find w, x, y, and z. So the corresponding elements are the same. So we have x plus 2 equals 2, so x has to be 0. Y minus 5 equals -4, so y has to equal 1. W equals 5. 3z equals -3, so z has to equal -1.